Alright, so this is how your notebook looks like. Now before we proceed to with the hands-on session, I would like to take you through the table of contents. You can click over there, the bulleted points, and this shows what are we going to cover in this data pre-processing module. First, I'll be taking you through what is a data and what are the different types of data which we will be handling while we are working with different machine learning models. And then we'll be looking at how to handle missing values when we are working with different types of data set. There are chances that we might encounter a couple of missing values in the data set, and machine learning model doesn't accept any missing values. So how to handle such missing values if we encounter them. And then we have categorical data encoding, and then how to split the data for train and test, and then finally comes the feature scaling. So this is our agenda when we are this is our agenda for data pre-processing. Now let's quickly begin with data pre-processing. Now, what is a data? As you can see, data is a collection of facts. It might be numbers, words, measurements, observation. Like you just type anything in terms of text, it's a data. You are speaking to someone, you're creating data, or you're trying to post a status in Instagram or in Facebook. Daily everyone are generating data. All right. So data, it's a collection of facts, numbers, words, measurement, observation, or descriptions of things. All right. Now, what are the different types of data which you'll be encountering? The types of data, first one is the quantitative data. Basically, the numeric type comes inside this one, and then qualitative data, where the categorical type of data falls into this category. Now, let's look at this picture. Coming to quantitative type of data, you can see a couple of examples like scores on exams like 85, 67, 90, and then the weight of a person or object. These are numeric. Your shoe size like 7, 8, 9, all these are numeric. But when you come to qualitative data, it's with respect to category type. For example, names like John, Patricia, Mary, or the type of smell, whether it's aromatic or buttery, and then the different type of colors like green, white, blue. So all these things come under qualitative. So you need to understand the difference between the numeric or the quantitative and the qualitative, because this is a very important thing, especially when we come to encoding part. All right. Now let's dive a little bit deep in quantitative data. So these are the data which deals with numbers. I can take a little bit of couple of examples like pressure, temperature, humidity, prices, area, volume, etc. And again, quantitative data is further divided into two parts, that is discrete and continuous. Now, discrete is like you can count it, or it has a finite number of possible values. All right, for example, number of students present in the class or number of items available in a grocery shop. So in both the scenarios, we can actually count. All right, we can have a count. This is like a finite number of values. But when we shift to continuous data, this is something like where it has an infinite number of possible values. For example, height of a person, like it can go to the lowest and the highest, and like we don't have a definite number. All right. And then the salary of person, for example, it can be 10 rupees, 25,000, or 1 lakh, or crore. It goes on, right? So this is infinite. Now moving on to qualitative data. In qualitative data, again, we have three different types. That is binary data. For example, yes or no, good or bad, right or wrong, true or false, something like this. And then in nominal data, we have, these are specially used for naming or labeling variables. All right. So this comes under nominal data. And coming to ordinal data, it's a categorical statistical data type where the variables have natural ordered categories. For example, I can tell you in a survey, you rate in a scale of 1 to 10, where 10 being the best and 1 being the worst. So this implies that 10 is better than 9, which is better than 8, and so on. Like each and every number has some meaning. All right. So this is something called as ordinal data. Now Let's proceed with the hands-on. So before we start our session or the hands-on, we start off by importing the necessary libraries for data pre-processing. So in this case, we need three libraries, that is pandas, numpy, and matplotlib. So let me import. So the packages are imported by the keyword import pandas as pd. Now import is a keyword to import this package, that is pandas, and instead of writing pandas every time in the program, I want to use a shortcut, so I write it as import pandas as pd. Alright, so in the program, if I want to use any function from this package, I'll just type pd in terms of pandas. Alright, now similarly I also want to import numpy. Right, import numpy as I want to use a short form like np, and I and pandas, we usually use pandas to work with data frames and a couple of other things, and numpy is specifically used to work with arrays because when you move forward, the machine learning models expect some data to be in terms of array, so we use numpy. And then we import matplotlib dot pyplot. So matplotlib is the package, and inside that we have a pyplot. There's one more, and I want to import or call this as in short form as plt. All right, so import matplotlib dot pyplot as plt. Now why is matplotlib used? Matplotlib is extensively used to create graphs, or I can say visualization, different types of visualizations. All right, let me run this block of code. You can either press shift enter. Alright, you can give run anyway. Now you can give shift enter to run the program, or you can just click this play button and it runs the program for you. Now you can see number 1 coming here, so it means that the block of code has been executed. Now let's move on. So here we need to load the dataset. I'll take you through the dataset. We'll be using pandas library to load the dataset. Now I'll download the dataset by clicking this link, the salary data. Just click this link. A new tab opens. So this is a CSV file. Let me just zoom in so that you can see clearly. All right. So this is a CSV file. We have 6 columns with the name of the candidate, state, the state from which the candidate belongs, profession. So what exactly is a profession? Whether is he a machine learning engineer or a data science engineer, or there are two different things. And then what is the age of that person? And then what is the monthly income of that candidate? And the last column indicates whether that candidate has purchased any item for a particular month. So S indicates that that candidate has purchased something in that month. No indicates that that person did not purchase anything for that particular month. All right. So we will be using this data set to work with data pre-processing. All right. So you need to download this. Click on this option, download. If you want to save the file, click OK. Alright, my file has been downloaded. Now go back to the Google Colab, and before you import the dataset into the Colab platform, you need to load the dataset. Go to file section over here and then click upload, this one, and then go to downloads and just type salary dataset.csv and click open. Yes, click OK. It just says that after you close this Colab platform, your data is going to be recycled. It's not going to be permanently there. All right. So you can see that salary underscore data.csv is there and it's uploaded. Now you can close this and let's load the data set. I will define a variable df is equal to, and I'll use pandas pd, and I'll press dot, and inside dot I would like to call the function read underscore CSV. Alright, I'm trying to read a CSV and put two round brackets and mention the name of the CSV file. Now please be very careful here. You need to mention the same, exactly the same way how the name of the file is, like capital S and capital D and underscore in between. Alright, so salary underscore data dot CSV. So let me mention the same. So salary underscore data dot CSV. Alright, now let me run this block of code. So what this block of code is doing is it's trying to read the CSV file and it's trying to store it in a variable df. Alright, so let me run this block of code. Alright, you can see the number 2. That means that the code has been executed. Alright, so this is the description. I'll be speaking in a while. Let me just try to display the data set. Alright, so my data set, as I told you, it is stored in the variable df. So let me just type df and run this block of code. So here is my data set. So this clearly confirms that the pandas has read the CSV file and it has stored it in data frame, right? Now the first column, this is the index column. It is just given random numbers 0, 1, 2, 3, 4, 5, 6, 7. There are totally 14 people. Okay, for if 0 is added, it's going to be 15 people. And the name, states, profession, age, monthly income, and purchased any item. Now let me just show you this one. The name indicates the name of the person, and the states, as explained, it is a state from which the candidate belongs to, and then the profession of that candidate, and the age, the monthly income of that candidate, and whether that person has purchased any item. Alright, now you can see that this data frame has a combination of numeric as well as categorical variables. Alright, so name column has unique categories, like there are the names are very unique for all the 15 rows, and states we have Mumbai, Bangalore, Delhi. So there are three categorical variables, that is Mumbai, Bangalore, and Delhi. And coming to profession, we have two, that is machine learning engineer and data science engineer. And age is completely a numeric data. It's not a categorical. Monthly income is also a numeric data. And then purchased any item is a categorical variable. It's a binary data, that is yes or no. All right, you can see the same thing over here. All right. So this was all about loading the data set and then displaying the data set. Okay, let's move on. Now here comes something called as dividing the data into independent and dependent variable. Now why are we even doing this? Because before you train a machine learning model, it expects the data to be in this format. All right, separate variable for independent column and a separate variable with a combination of dependent variable. All right, now before moving on to the data set, I would like to explain what exactly is an independent and a dependent variable by taking a couple of examples here. All right, now I have the height of the plant over here. Right, this is the dependent variable. I'll tell you how it is dependent variable. All right, and here also we have height of the plant, and then we have the amount of water. Now the amount of, carefully listen to the sentence which I'm going to tell. The amount of water which you are going to feed to the plant depends on the height of the plant. All right, let me repeat the sentence. The amount of water which you are going to feed a plant is going to depend on the height of the plant. All right, similarly for the amount of fertilizer. The amount of fertilizer which you're going to give to a plant depends on the height of the plant. That is why height of a plant is a dependent variable. Alright, while amount of water and amount of fertilizer is an independent variable. Alright, okay, let's move on. So this is the the exact explanation, and in our example it was the height of the plant which was the dependent variable, and the amount of water and amount of fertilizer was the independent variable. But when we come to our data set, all right, here you need to remember one thing. All right, in this data set, purchased any item is a independent variable. All right, and the profession, age, and monthly income is a dependent variable. All right, so in our data set, okay, in our data set, let's try to identify which is a dependent variable and which is not which is a independent variable. All right, let's try to differentiate a dependent and an independent. Now in our data set, the dependent variable is the purchased any item column, and the independent variables are profession, age, and monthly income. Now, I'll tell you why didn't I mention name and state. Now, the purchased any item doesn't belong to a name. Like name is just a unique thing, all right, and neither it depends upon the state. All right, in exceptional cases, if you're trying to analyze, with respect to city, then yes, states comes into the picture. Otherwise, it's just the profession, the age, and the monthly income of a person which decides if whether a person has purchased any item. All right, this is in our case. Now this is going to vary with different data set. All right, so but in my case, profession, age, and monthly income are going to be independent variable, and purchased any item, this S is going to depend on monthly income, age, and profession. All right, let's move on, and that's what I've written here. And I've also mentioned that you need to eliminate those columns in which all the data are unique, because dependent variable will never depend on the column in which all the data are unique. For example, name, ID, roll number, all these, it's just for identification, but it doesn't contribute to model building. All right, it doesn't contribute to the depending column. All right, now let's move on. Now here what I'm trying to do is I'm trying to variable capital X, and I'm trying to get some of the columns out from the data frame. All right, so I'm going to take the independent variables into variable X, that is states. All right, let me consider states and profession, and then the age and the monthly income. Be careful while typing, because the column name has to be same, just like the way you're typing with respect to capital letters and underscores. All right, so as I told you, that let's also consider states when we are using the dependent. All right, so but in some cases you will not be requiring states, but in my case, let me I have decided to take up states which will be contributing as an independent variable. All right, now let's move on and keep the variable, that is purchased underscore any underscore item. All right, so what this block of code is doing is, in variable X, it's trying to take these column states, profession, age, monthly income, and keeping only these columns in X. These are the independent variables, and our dependent variable, that is purchased any item, is going to be stored in variable capital Y. All right, let me just run this block of code, and let's also try to display dot head and display I dot head. All right, don't forget to put the round brackets. Let me run this block of code. Now head displays the starting 5 rows, all right, of a data set. Now with respect to X, as I told you that we have eliminated a name and name column. All right, and we have used states, profession, age, and monthly income. All right, and these are my independent variables, and we have one dependent variable, that is the last column, that is purchased any item, that is in Y. Alright, X is this one and Y is the second data frame. Alright, now there are other ways also to do this. Alright, what I can do is again create a variable X is equal to and df dot use iloc. Now what is iloc? Loc is the location and I is the index. Alright, so I'll be defining the range. Now the starting range, I'm going to just put a semicolon which clearly states that I'm going to take all the rows. Alright, the first argument inside the square brackets is with respect to the rows, and the second argument I'll be mentioning to start with 1 and end it with fourth column. Remember, the when you mention 5, it's going to take n minus 1 into consideration. For example, first when you go back to the data frame, you can see that this is an index 0, 1, 2, 3, 4, 5. Alright, now I'm going to take it from 1, that is states 1, 2, 3, 4. Right, I want only the 4 columns, that is with index 1, 2, 3, 4. But when you're writing, you need to write it as 5 because it doesn't consider the fifth column. Alright, so 1 is to 5. Let me just keep this and also take the dependent variable in variable Y. Right, so df dot iloc, and then I want all the columns. I'm not going to eliminate any column, but then I want the fifth column. Alright, so I can just mention it like this. Alright, so fifth, all the columns after fifth, so there's only one column, so it will be considering only one. Alright, that is a purchased any item. Right, so let me just run this block of code and try to execute. Copy the same code and just run it over here. Run this block of code, and you can see that it's again the same things coming up. Alright, okay, let's move on. And there's one more way where you can get the independent and dependent variable without column name. Right, here you're getting the column name. If you don't want this, you can always eliminate those by using another syntax. The syntax remains the same. This one, let me just copy the same code. If you don't want the columns and if you want only the values, just mention dot values. Alright, so just mention dot values and run this block of code and try to display X as well as Y. So you can see that there is no column, it's just the values coming out. Alright, I hope you understood the difference between this one and by mentioning the values, what is the difference in the output. Alright, now let's move on, and now there's one more method how you can do this. Alright, so I want to show all the possible methods what you can use so that you're comfortable using whichever you feel it's easy. Alright, so you can use the same method throughout the machine learning course. Alright, so X is equal to df dot, I'm going to draw a couple of columns and keep all the rest of the columns of the independent variable. I want to drop the name column. Alright, and also I want to drop purchased underscore any underscore item, and you need to mention axis is equal to 1. Default axis is 0, that is it's going to search for the column, but here we are trying to eliminate from the default is going to search in rows. So if you mention axis is equal to 1, it's going to search in the column and try to eliminate these columns which you have mentioned, that is name and purchased any item. And in variable y, I need df of only one column, that is purchased underscore any underscore item. Alright, so let me just run this block of code. Alright, so remember, when I'm only using the drop function, I'm trying to mention the access. If you're trying to take directly the column, there's no need to mentioning, there's no necessity of mentioning any access is equal to any particular thing. Alright, now let's check if this has worked properly. I'll try to display x dot head, and similarly I'm trying to display y dot head. Alright, so let's see. Yes, we exactly have the same thing. So there are three different methods. What you can do, this is the third method which I've shown you, like drop the name and a purchased any item column, and and put out and keep all the independent variables in x variable, and the dependent variable, that is a dependent column, that is purchased any item, in the variable y. All right. So let me just take you through what and all we have discussed in this lecture. We started off by understanding the different types of data, and then we imported the necessary packages. I also told you what is the necessity of each and every package mentioned here, and I also told you the importance of each and every package mentioned here. We loaded the data set. Don't forget to upload the CSV file. All right, and then we moved on. We displayed the data frame, and then we tried to separate dependent and independent variables by three different methods, by mentioning directly the columns, or you can also use iloc function, right, the location of the index. And then we also used a drop function, and one more is df, and we mentioned directly the column name, and we have separated two different things, that is dependent and independent variable. Alright, now in the next lecture I'll be taking you through how to handle the different missing values which you'll be encountering in the machine, in the data, in a data when you're trying to train a machine learning model. Alright, I'll catch you in the next lecture. Thank you.